Hello everybody, my name's John Handler. I'm a solutions architect with AWS, and I will be talking to you today about Amazon Elasticsearch Service and UltraWarm. I'll be joined for the second half of my talk with Robert Kamau from PayPay Corporation, and he will talk through some of the ways that they have used Amazon Elasticsearch Service and UltraWarm at PayPay. Amazon Elasticsearch Service is a fully managed service that makes it easy to deploy, secure, scale, and monitor Elasticsearch in the AWS cloud. You use Elasticsearch for storing and analyzing your log data from your infrastructure logs, your IoT logs, your AWS service logs. All of that data you're going to bring to Amazon Elasticsearch Service, and then you're going to use the bundled Kibana to view and analyze, search and analyze that data to find issues and performance of your infrastructure and applications in the cloud. With Elasticsearch, you are storing all of that log data. The more log data you bring in, the more that you're storing. The cost of the solution is going to grow linear with the amount of data you store. So effectively, you're limited in the amount of data that you can put into a single Amazon Elasticsearch Service domain. On the other hand, Elasticsearch is most typically used, and especially for monitoring, is used to monitor in real time what's going on with your infrastructure and application. In other words, the last 15 minutes are actually the most important to you. The value of your data drops rapidly as time progresses. So on the one hand, your cost is going up, and on the other hand, the value of the data is going down. Now, there are some cases where you really do want to store your data for a long-term retention. Some forensics and other regulatory workloads need to have a long-term storage. So we came with UltraWarm as a feature for Amazon Elasticsearch Service that enables you to store that data for a long period of time at close to an S3 cost. In other words, we reduced the cost dramatically for storing data for a much longer time period to enable you to continue to access that data with Elasticsearch. So the core idea is to extend your data retention and enable you to do that at a much reduced cost. Now, with UltraWarm, you're going to use exactly the same REST APIs and exactly the same Kibana dashboards that you've already been using. In other words, the access to your data remains seamless. You don't have to think about the storage tier of that data. And because that data is in S3, what we're going to do is we're going to trade latency of accessing that data for the cost of retaining that data. So your longer-term retention will provide you a lower level of access. It'll be a longer latency to access that data, but you'll be able to do that at a reduced cost. And that will get you to an optimum cost balance for the amount of data you want to retain and the amount of time you want to retain it. With all of that, you can achieve substantial cost savings by putting your data into UltraWarm compared with storing that data in hot. If we look at a somewhat manufactured use case, and we have here on the x-axis the amount of data ingested per day. On the y-axis, we have the cost of putting that data into the hot tier of Amazon Elasticsearch Service. If we're storing data for 90 days, we can see as the data size grows, the cost grows out to about $900,000 per month for a petabyte of data in the service. If you use UltraWarm, however, we take the same 90 days of data and we retain 7 days in our hot tier and 83 days in our UltraWarm tier. We can drop the cost of storing that data down to $157,000 per month on demand. That represents about an 82% cost reduction. Your actual mileage will vary, and so your savings will not be exactly 82%. It kind of depends on how much data and the ratio of hot to warm. However, we achieve substantial cost savings across the board. So let's take a little bit of a dive into UltraWarm and talk about how to work with it. When you use Amazon Elasticsearch Service for logs, the best practice and the usual way that you do it is to build a rolling index pattern. So you're sending your log data to Amazon Elasticsearch service. There's a number of different ways that you get data in. We won't detail those today. But you're creating an index. Index is like a database table. It's an organization of the data. So I'm going to have all of my logs from, say, November 10th in an index. November 9th will be in a second index. And when I refer to the data, I'm able to hit the various indexes to pull the data to analyze it. Usually you create indexes on time or size boundaries. Kibana then is able to build the visualizations and dashboards based on the time frame that you select for that visualization or dashboard, backing out to the indexes to figure out which data it needs to access. So when you manage data lifecycle in Amazon Elasticsearch service, that is through a time-bounded, usually, index. When you use Amazon Elasticsearch service, you create a domain. Domain wraps software and hardware that delivers Elasticsearch to you at a REST endpoint. Underneath the covers, Elasticsearch is a distributed database. So you're working with a set of instances that provide the capabilities of Elasticsearch, and the requests will go to those indices. So the data nodes, we have different node types. Data nodes are the worker nodes. They're going to index and analyze your data. We also have dedicated leader nodes. These nodes maintain the cluster state and keep the cluster functioning as a cluster. The data nodes then are going to either use on-instance or network-attached storage for storing the indexes and for accessing the data. When you use UltraWarm, UltraWarm nodes are data nodes in the cluster as well. So UltraWarm nodes are the same kind of nodes, they're data nodes. However, UltraWarm stores its indexes in S3. Elasticsearch then is going to route the requests seamlessly, and your requests themselves are actually just going to go to the nodes where the data is stored so that the requests are processed. When you use UltraWarm, you're going to manage the life cycle of the data at the index level. So your data is stored in an index, and the index is initially created in the hot tier. The hot tier is where you're going to store your index. It's where you're going to get the fastest access to your data. So generally, you would keep a few days of data in your hot tier. You are then going to migrate that index from your hot tier to the UltraWarm tier. You can do this via an API call. So for a single index, you can call the UltraWarm migrate API to migrate a single index onto the UltraWarm tier. During that migration, we're going to perform several maintenance functions on that index to prepare it for UltraWarm. The first of those is we're going to force merge. The second is we're going to drop replicas. So with Elasticsearch, you generally use at least one replica to provide yourself with redundancy and durability in the face of possible node failure. Well, we already have durability and redundancy in UltraWarm because the data is stored in S3. So we're going to drop any replicas. We're then going to use a snapshotting process to migrate the data itself into S3 and load it into that UltraWarm node. We also have an automated way that you can migrate the indexes, that you can do index management. And this is called our index state management feature or plugin. We have essentially a finite state automaton that you build that tells Elasticsearch, tells Amazon Elasticsearch Service how to treat your indices. In this example, we can see we start in a warm state. After 7 days, we'll transition to, we start in a hot state. After 7 days, we'll transition to the warm state. And then after 90 days, we're going to delete that off. We have a set of actions and transitions that you specify in your JSON policy that are fairly declarative, and it should be easy to set up a policy like this. You can also use a template to assign policies to new indexes as they're created. You can see our documentation for an example of that. So far we've talked about how UltraWarm works, and we've talked about the cost savings. We have to talk a little bit about the trade-offs. I'm sure everybody's wondering, okay, well, this data is living in S3. How fast could it be? Well, we actually have built UltraWarm to use the UltraWarm node as a local store to mediate trips to S3. So essentially, when you access your data via query or Kibana visualization, we're going to pull the data from S3 onto that UltraWarm node for local storing and improving the access speeds for accessing that data. So if we have already cached that data in the UltraWarm node, we get like-hot performance. That's order of milliseconds for these queries. Otherwise, the query latency really is going to be dominated by the amount of data you've accessed and the trip to S3 to retrieve that data. So if we have smaller slices, which is very typical for Kibana, you're using a small time slice to look at data, and there's not too much data, we have an expectation. Queries should run, visualization should build on the order of seconds. As you scale up and as you get out to scale, we see that grow out into the minutes for petabyte scale queries. So we do have a performance penalty that comes with the cost savings, but in most situations, when you are accessing a dashboard or doing some forensic work that's going to repeatedly access the same data set, you're not going to pay that penalty more than once. We provide two different UltraWarm instance types. We have an UltraWarm 1 medium and an UltraWarm 1 large. I've put the specs of those instances up, mostly so that you can understand and do planning and sizing. The UltraWarm medium is able to manage 1.5 terabytes of data in S3. It is a 2 CPU instance, and it has a 475 gig local cache. So we're managing 1.5 terabytes with about 500 gigabytes. In other words, we have about a 1-to-3 ratio here. Keep that in mind as you think about how many nodes you're deploying and how much data you're deploying against. Also, we have a 2 CPU instance, so queries that are accessing hundreds of shards are going to have to do it with those 2 CPUs. So again, when we're looking at small slices of data, we're going to get great performance. As we scale up and access more data, performance will go longer. On the large instance, you can manage up to 20 terabytes of primary index. It has 16 CPUs and 3.8 terabytes of local storage. And here we see a maximum of about 400 shards on the medium, a maximum of about 1,000 shards on the large. I had some other ideas about cost considerations that I wanted to share with you today. We'll just go quickly through these. When you use Amazon Elasticsearch service, you're charged along 4 different dimensions. The first of those is instance hours. You choose the instances to deploy in your Elasticsearch service domain, and you are running against those instances. We charge per hour for the instances that you have deployed. Second component is storage. You could choose instances that are EBS backed, or you could choose instances for your data nodes that are backed by Instance Store. If you choose EBS backed instances, we're going to charge per gigabyte of EBS volume deployed. When you use UltraWarm, we also charge for the S3 storage of your data. And finally, we charge data transfer at normal EC2 cost. Now, if we look at all of these components, the instance hours is going to be the primary component of your costs. So that's where you want to try to optimize is the instances that you're running, the instance size, the instance type, and the instance count. Secondarily, again, as we come back to the first point of the talk, the more you're storing, the more you need to, the more instances you need to hold the disks to store that data. So the storage itself can be a second component that drives cost. If we think about managing cost, number one, we want to use reserved instances. That's a very quick way for you to reduce cost. You can get up to a 30% price reduction just based on a no upfront 1-year commitment. Second of all, pay attention to the data that you're sending to Elasticsearch. If you can reduce the data that you send, you reduce the data that you store. So look at especially Logstash and other ingestion tools and make sure that you're dropping all of the data that's not contributing to either search or analysis in your usage. You want to evaluate additional redundancy for the ROI. Our best practice is to use 1 primary and 2 replica shards. That second replica can drive quite a bit of cost and can also provide you with additional stability. So evaluate the ROI, choose 1 or 2 replicas, but make a choice in terms of the ROI of that second replica. You can adjust your mapping, and I have some ideas here about how to address that mapping to reduce the overall on-disk size of your indices. You always want to set a template in a log analytics workload. This will help you manage your shard count. It will help you manage all of your mapping. And it will, if you enable dynamic to strict, in other words, if you refuse to index unrecognized fields, that also helps you keep a control of what you're indexing. If possible, remove your source data from all of your fields. Don't store that in Elasticsearch. Use a secondary store to retrieve and display that data. Text fields, by default, will create a second copy of their data. If you set an explicit mapping, you can override this and avoid that second copy of your data. And finally, look at your retention window. Try to decide how long you really want to retain that data and make a conscious choice about how long you need that data to have very low latency access and whether UltraWarm can bring cost benefit along with the trade-off of a little bit longer latency and access. Just a couple of anti-patterns to mention. So UltraWarm indices are read-only. It's really only appropriate for workloads where you don't have updates. So search workloads generally don't fit well with UltraWarm. Your performance is going to be proportional to the shards you put on the instances, the UltraWarm instances, and the amount of data you access. So be careful about accessing hundreds or thousands of shards in UltraWarm and petabytes of data. The expectation there is that the queries can run out into the minutes. Also pay close attention to the shard to CPU ratio. In the capabilities slide a few slides ago, I mentioned a shard limit, 400 for the mediums, 1,000 for the larges. Really, that's just a way to get a handle on how many shards there are vying for those CPUs. So pay attention to that, how many shards you have, where you can reduce shard count, always to the good. The migration process can run a long time. And when it does, the migration process itself is single index and single shard concurrent. So be aware that if you have a lot of single shard indexes, that migration can take longer just based on the concurrency of the migration that we do. So again, larger indexes that have more shards will get more parallelism for the migration. Finally, if UltraWarm is not performing, you can tweak it by overscaling the UltraWarm tier in order to get better performance. In other words, in order to get better shard to CPU ratios, in order to get more CPUs against the workload, and more cache against the workload, you can go at a thinner rate than 1.5 terabytes per medium or 20 terabytes per large. You could do 1 terabyte per medium. You would then trade back some of the cost benefit and get some performance benefit out of that. Thanks very much. I'm going to pass it over to Robert from PayPay, and he'll take us in from here.
So thank you, John, for the detailed introduction about Amazon ES and UltraWarm feature. From here on, I'd like to explain our use case at PayPay, our UltraWarm use case at PayPay. My name is Courier Robert Kamau. I'm a platform engineer with PayPay based here in Tokyo. Allow me to briefly introduce PayPay. So what is PayPay? So PayPay is Japan's leading mobile payment app. We went live on October 5th, 2018. So currently it's a little over 2 years since we went live. And PayPay first started as a QR code payment app. But currently with your PayPay app, you can not only purchase at your favorite online and offline stores, but you can also pay your utility bills from home without having to go to a bank or a convenience store. You can do P2P with anyone having the app by either sending or even requesting a transfer. So recently we've launched a feature where you can search your favorite store or food joint and place a pickup order with your PayPay app. So this feature actually has Amazon ES as a backend for store search. And these are just but a few in a line of cool products by PayPay. And just to give you a picture of how PayPay has grown within the 2 years. As of June this year, we've reached 30 million users and 2.3 registered stores here in Japan. As for the 2 years, we've also recorded a total of 1 billion transactions. This is enormous growth for a startup. With this kind of product growth, we've also seen an increase in the number of microservices that support our product. This increase in microservices has led to the need for a robust logging system, which we've implemented with AWS ES. So from here, I would like to explain how we've implemented our logging solution with AWS ES and how we are utilizing UltraWarm. So this is our logging platform overview. So we have over 120 microservices deployed on Kubernetes. These ones are sending application logs to Kafka with Log4j configurations. We then fetch logs from Kafka using Logstash and ingest to both Elasticsearch for near-real-time search and near real-time search and S3 for archive search. Our logging system literally drives our business, both for our backend engineers, for debugging, the dev works, and also for our customer support. So here's an overview of our cluster and index size before introducing UltraWarm. We had a total of 57 cluster nodes, 3 master nodes, and 54 data nodes. Each data node has an EBS size of 6.1 terabyte, making a total of 329 terabyte for the cluster capacity. And we have daily rotated indices. Each index is currently 2.8 terabyte, making it 5.6 with one replica. And before introducing UltraWarm, we were using Curator. It's a tool for housekeeping indices, and we used to delete any data older than 1 month. So next, I want to talk about how we monitor our Amazon ES cluster. So these are some of the major metrics we monitor on a daily basis. So we have the memory pressure, we have the CPU utilization, disk capacity, and so on and so forth. So for these major metrics, we have the anomaly alerts on PagerDuty for immediate response, as these are resources that would cause if they are depleted, these are resources that would cause severe impact on our logging service. We also perform some basic but very important index tuning for our use case. We set the number of primary shards, same as the number of data nodes, to be able to distribute the writes and disk space among the data nodes. So initially with the 5 primary shards, which are the default settings, we had a case where only 5 nodes had high load and running out of disk on those nodes. So to kind of, with the ingestion rate, like the ones we have for our use case, so we had to, find a balance between the number of shards and the kind of the right distributes we wanted. We also raised from the default settings like the index translog threshold hold size and the refresh interval to somehow relieve the cluster of the internal index operations load. Still, with these optimizations, we still had some challenges due to the daily increasing log volumes. So the graph here shows the increase in our log index in a span of 4 months, where we had, on average, an increase of 600 gigabytes per month. Due to this, we've had to scale out data nodes to keep up with the volumes and also provide the same SLA, leading to increasing costs. We could also only retain 1 month of logs in ES and had to delete logs older than 1 month from ES and use Athena to search anything older than 1 month. We also had to reserve a service maintenance type for any domain configuration changes. Let's say you want to change the instance type, or you want to add some config that is going to trigger a blue-green deployment, because this would cause Kibana downtime and the large amount of data you have in your ES cluster, the longer this is going to take. And so we have those challenges, and so we had to introduce at this juncture UltraWarm to see how it's going to help us, especially with our increasing data volumes. So these are the steps we took to introduce or to set up UltraWarm in our cluster. So we had to first upgrade our domain from 6.2 to 6.8, which is the minimum requirement for UltraWarm. And with this, actually, we had to set up a separate domain as an actually do multiple writes to both these clusters that we're introducing UltraWarm and a new cluster. So this way, like user, you still continue using the separate domain as an in-place upgrade. In-place upgrade of this cluster would cause like a downtime of Kibana for long periods, which would impact our service. And then after that, we added warm nodes, 15 warm nodes to the cluster, after which we migrated all the old indices from the hot tier to the warm tier. And then after that, after migrating all the old indices is when we enabled the automatic warm migration using index state management. And with this, one of the things we did is like you'll notice like during the warm migration, your cluster will be will have high load compared to a daily basis because of the warm migration itself. And for this, we didn't want to do that during business hours, so we had to kind of tune it so that it comes to non-business hours or during the night when you know, like non-business hours for our PayPay product. During index warm migration, we found it was initially taking over 3 hours to migrate a single 2.6 terabyte of index. We later realized we had hit the EBS throughput limit with the R5 instance type. This is the read, especially on the hot tier. And we had to change to an instance based, SSD based i3 instance. And with these, we were able to do the migration just over a little bit of 2 hours. So after introducing UltraWarm, so this is our cluster overview. So we had an extra storage tier where we can store logs up to 3 months, and this is the UltraWarm or the warm tier. So we, however, still ingest logs to S3 as a legal requirement, but the need to actually search logs from Athena is comparatively low compared to before introducing Athena UltraWarm. So next, I would like to highlight on the search performance differences between the hot and warm storage tiers, or before introducing UltraWarm and after. And for this, I had to actually measure with a real use case query, doing a unique count of the number of integrated microservices into our ES cluster. So what I did here, I took a 7-day sample of the query's response time, both in the hot and the warm tier. And as you can see, there's a good 1.2 second increase in latency for the warm tier. So for a use case where almost all searches are on Kibana, it's almost a negligible change. But for some use cases, 1.2 seconds is a huge difference. So something to consider depending on the use case. So here is a summary of the effect of introducing UltraWarm. Before UltraWarm, we have 57 cluster nodes, could only keep data in ES for 1 month. And after UltraWarm, we managed to reduce the number of nodes to 44 nodes. But we were able to increase the log search in Kibana to 3 months. And the biggest part of it, of course, for us is the cost reduction part. So initially, and even before adopting UltraWarm, we were using RI, reserved instances, for all our hot nodes to reduce the costs. And although UltraWarm nodes currently don't offer RI, we managed 40% in cost reductions per month, which is a huge boost for us. So going forward, we still have some few challenges and things like we would like to improve with our logging experience. First is the Kibana downtime issue. We hope with less data in the hot tier, Kibana downtime during blue-green deployments would be shorter, but it's something we'll have to check and see how we can improve. And next is a domain resource spike. We've seen like sometimes like when people are doing searches in Kibana, you'll have spikes like memory spikes and CPU spikes depending on the query. And we've had to frequently clear cache or to prevent cluster downage. So we are trying to find a good way to curb this. And last but not least, we are planning to optimize our field mappings for our log documents to reduce the storage size, something John highlighted earlier on. So thank you very much for your time. This concludes my presentation. I hope you at least got an idea, an idea of an ideal or real-time AWS ES UltraWarm use case. And yeah, please remember to complete the session survey. So thank you very much.